Hi everyone. Today is a day I've been looking forward to. We're going to start talking about systems of linear equations. Um, this is actually my favorite chapter in all of linear algebra, so hopefully you like it. So let's move on. So let's talk about systems of linear equations. Today we're going to talk about solving them by graphing them. But before we get going, we need to know what a linear system is. Um, a linear system are two or more linear equations. They can be in any format. They could be in our, slope-intercept form, our standard form, our point-slope form. But we have two or more linear equations. What's a solution? A solution to a linear system is a point where the two equations intersect. So if I have one equation here, the point where they come together is the solution. Well, how can you tell? Well, there's numerous ways to see what is a solution to a linear equation. But if you're given 2 points and if you want to know if they are a solution, one way you can tell is just to plug them in and see if they work. So let's try that. If I say a is -2 and y, x is -2 and y is -3, if I plug them into both of these equations, they should both work. So if I did 2 times -2, and I subtracted 1, do I get -3? Well, 2 times -2 is -4. -4 minus 1 is -5. It is not -3. So that does not work for the first one. Therefore, I know it's not a solution to both because it's not a solution to A. I could check out B, test it out. If I put a -2 here, I will get a +3 actually. No, I will get a 7. -2 will give me a +2 plus 5 is 7. So that doesn't work. Let's try the second one. 2 times -3 minus 1. Does that give me +2? Well, 2 times -3 is -6. -6 minus 1, again, does not equal +2. So that is not a solution because it's not a solution for the first one, so it can't be a solution to both. To be a solution, it has to be a solution to both. Let's try the next one. 2 times 3 minus 1. Does that equal 2? Well, 2 times 3 is 6. 6 minus 1. Does that equal 2? No. So that, again, doesn't work. It is not equal to 2. So hopefully the last one works. Plug in 2. 2 times 2 minus 1. Does that equal 3? Well, 2 times 2 is 4. 4 minus 1 does equal 3. So this ordered pair does work for the first equation, but in order to be a solution to a system, it has to work for both. So now let's try it on the second one. If I plug in 2 for x, I would get -2 plus 5. Does that equal 3? And it does. -2 plus 5 does equal 3. So this set of ordered pairs, 2, 3, works for both my first equation and my second equation. So that is a solution. Okay, so now this is kind of an opposite question. It says, for which of these systems is negative 3, 5 a solution? So again, we can plug it in and go to, I'm going to plug in my negative 3 here. 2 times negative 3 plus 5, does that equal negative 1? Well, 2 times negative 3 is negative 6. Negative 6 plus 5 does equal 1, so that did work. But if I put in negative 3 here for x and 5 for y, negative 2 times 5 is 10. Negative 3 plus 10 does equal positive 7. So this is a system that negative 3, 5 is a solution for. But we want to check other ones just to see. So if I put in my negative 3 here, negative 3 times 4 is negative 12. And 3 times 5 is 15. Negative 12 minus 15. Well, yeah, that's negative 27. Let's try my next one. 2 times negative 3 is negative 6. 4 times 5 is 20. Negative 6. Oops, I didn't write the 5 in there. Negative 6 plus 20. Is that positive 12? No, that's positive 14. That did not work. So it is not a solution to this system. It was for the first, but not for the second. To be a solution for a system, it has to work for both. Let's try the next one. I have 5 times negative 3. That's negative 15 minus 3 times 5. Well, negative 15, 3 times 5 is also 15. So negative 15 minus 15 does not equal 12. So that one didn't work for the first one. I don't even have to try the second one. If it doesn't work for the first one, I don't even have to try the second one. What 3 times negative 3? That's negative 9. 2 times 5 is 10. Negative 9 plus 10 does equal a positive 1. So it does work for this one. Let's try the next one. 6 times negative 3. That's negative 18. 4 times 5. 4 times 5 is 20. You might be start thinking this one's going to work because 18 and 20, but we're subtracting. Negative 18 minus 20 is negative 38. It is not 2, so this one does not work. So my answer is A. So you might be thinking to yourself, man, there has to be an easier way to find solutions. You can't just randomly pick ordered pairs and see what works. Well, there are. We actually have a number of ways we can solve systems of equations. So the first way we're going to do is graphing. So let's take a look at this. I have a linear equation right here, negative 2x plus 7. Let's graph it. I'm going to go up 1, 2, 3, 4, 5, 6, 7. Put a dot. My slope is negative 2, so I'm going to go down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. Normally I wouldn't make all of these points. I would just, make a couple and connect them. But drawing with my mouse is not the, I don't draw the straightest line, so I want to make sure I have my actual points marked. I can also go up 2 and left 1. So this would be my last point I can put on there. I'm going to try to connect them to the best of my ability. Again, that's why I marked my lines so that when I draw squiggly, at least I know where my points are. Now let's graph my second line. I have y equals 1/2 x minus 3. I'm going to change my pen color so we can see my other line. My y-intercept is -3. 1, 2, 3. And my slope is 1/2, which means I'm going to go up 1 over 2. May as well connect them as I go. Up 1 over 1, 2. And look at this. Here is my solution. This is where these lines cross. So this is a solution to my linear equation where these lines intersect. So it's at 1, 2, 3, 4, 5. Oops, nope. 1, 2, 3, 4, -1. So the solution to this system of equations is 4, -1. That means if I plug in 4 for x and -1 for y, it will work. So if I did -2 times 4, that is -8. -8 plus 7 does equal -1. So it works. I should have used I should use my red pen for that one so you can see that that's this equation. But I'm not going to go back and change it. Here I get half of x. Well, half of 4 is 2. 2 minus 3 does in fact equal -1. So this point works for both equations. So that's why it's a solution to this system. Okay, let's look at my next one. I have y plus 4 equals -1/3 x minus 3. Well, how do I graph this? Hopefully you remember from our last unit that we can pull out a point. X is 3. Y is -4. This isn't the solution to my, this is just how I can graph it. Y is -4. And my slope m is -1/3. So I'm going to graph this point 3, -4, 1, 2, 3, -1, 2, 3, 4, and I'm going to put a point. And then my slope is -1/3, which means I can go down 1 and run 3, but I'm going to run off my graph. So I'm going to go up 1 and left 1, 2, 3. Oh, that's a bad line. Up 1, run 1, 2, 3. Up 1, run 1, 2, 3. And that would be the graph of this line. Well, let's try my other line. X plus 3y equals 12. Remember, I can find my intercepts for this one, and then connect them to form a line. Since this is in standard form, if I make x 0, my y, 3 times what equals 12, would be 4. Because 3 times 4 equals 12. If I make x 0, this goes away. If I make my y 0, I have x equals 12. If you can't remember how to do this, you might want to review standard form from our previous unit. Okay, so let's graph this. 0, 1, 2, 3, 4, and 12, 0. I have a problem. I cannot graph 12, 0. So if I can't do that, I might need to rewrite this one in slope-intercept form. To do that, I need to subtract x from both sides. How would you know my y-intercept? So if I subtract x from both sides, I will have 3y equals -1x, negative x plus 12. Then I'm going to divide both sides by 3. And I get y equals negative 1/3. Uh-oh. Negative 1/3 x. You'll see why I said uh-oh in a minute. And 12 divided by 3 is 4. Well, my slope here is negative 1/3, which means I go down 1, run 3, down 1, run 3, up 1, run 3 to the left, up 1, run 3 to the left. You'll notice I have parallel lines. Well, what happens if I have parallel lines? These lines are never going to cross. I'm never going to have a solution to this. This would be no solution. There is no point where these two lines will intersect. So that is no solution. Can that happen? Absolutely. And you'll find that when you have the same slope. I did clear that. Sorry. Okay, now I have another one. I hope I can. This one's not going to be very nice to graph because my x-intercept is going to be a fraction. So I might want to rewrite that one in slope-intercept form. This one, I have an x of 6 and a y of 1. I can pull that point out from here, and my slope is 2/3. So I'm going to go to 1, 2, 3, 4, 5, 6, and up 1. My slope is 2/3, which means I'm going to go up 1, 2, and run 3, but I can't do that. So I'm going to go down 1, 2, run 1, 2, 3 to the left, down 1, 2, run 1, 2, 3 to the left. And connect my points. It was a relatively straight line for me. This one, not so much. Well, maybe I can get it. And it will keep going. Okay, let's rewrite my second equation in slope-intercept form. First, I'm going to subtract 2x from both sides. The only reason I'm doing that is I know that if I make my y 0, I'm going to get 4.5. Not 4.5. Yeah, 4.5 for my x-intercept, and that's a weird number, so I don't like that. When I'm graphing, I don't like to have fractions, except for my slope. Fraction for my slope is fine. So I have negative 3y equals negative 2x plus 9. I'm going to divide by negative 3, divide by negative 3, and divide by negative 3. Oh, and I see this again. I get y equals 2/3 x minus 3. I notice I have the same slope again, but let's see what happens here when I graph this. My y-intercept is negative 3. My slope is 2/3. I'm going to go up 1, 2 over 3. See what's happening? Up 1, 2 over 3. This is the exact same line. Oh, what happens when you have the exact same line? You have infinitely many solutions. Every point that's on one line will be on the other line. You'll have infinitely many solutions. Okay, I have another example here. It's a word problem. I have two candles. I have a 10-inch candle, and it burns at a rate of 2 inches per hour. Then I have a 4-inch candle that burns at a rate of 1/2 inch per hour. You want to know how long till they're the same height? Well, let's start with the 4-inch candle. 4-inch candle is going to start at 4 inches, but it's going to go down 1/2 inch. Go down 1/2 inch every hour. That's going to be my equation for that line. My 4-inch candle going down 1/2 inch every hour. Well, if I graph that, it's going to start at 4 inches. And then every hour, it's going to go down 1/2 an inch. So my slope is -1/2, down 1 over 1, 2. You can see that after 2 hours, it's going down a full inch. Down 1 over 1, 2. And after 8 inches, it will be gone, which makes sense if it goes down 1/2 an inch every half hour. After 8 hours, it's going to have gone down 4 inches. Okay, let's look at my 10-inch candle. My 10-inch candle is going to start at 10 inches, but it's going to burn 2 inches every hour. Notice it's a negative. It's getting smaller by 2 inches every hour. So it's going to start at 10. Then after 1 hour, it's going to be 8. After 2 hours, it's going to be 6. After 3 hours, it's going to be 4. And so on. And there is a point where it's going to intersect. After 5 hours, it will be gone because 5 times 2 will burn all 10 inches. So after how many hours will it be the same height? And that answer is after 4 hours. Because after 4 hours, my 4-inch candle will be 2 inches. I put a 4 here. Half of 4 is 2. So -2 plus 4 is 2 inches. And my 10-inch candle, after 4 hours, will have gone down 8 inches. -8 plus 10 also gives me a 2. So that's a point where my candles will be the same height. So just a quick review. There are 3 different possible solutions to a system of linear equations. You can have one solution where the lines intersect at one point. So they cross. You can have no solution. That's where you have parallel lines. They're never going to cross. There's not going to be any set of ordered pairs that will be a solution to both equations. Then you have the infinitely many solutions. And that's where the lines are the same line. So every point is the same. That's it. Have a great day. Talk to you soon.